Earlier we covered installing Trident and configuring with two storage backends. In this section, we go over two basic examples of provisioning volumes with Trident. So the next step is to define a storage class. So as a storage admin, I come and define a storage class called ONTAP mixed. So let's see the definition for ONTAP mixed. So here we see that the provisioner for storage class ONTAP mixed is Trident. And for storage class ONTAP mixed, we have specified two storage backends. The first one corresponds to our NAS storage virtual machine. So if you recall, when we retrieved the list of all the backends, this corresponds to the NAS virtual machine, and the second one corresponds to our SAN virtual machine. And what you see after the colon is the storage pool that is attributed to that given backend. So you can find the list of storage pools that are in the backend by issuing the get backend call and getting the details of a given backend. So in this instance, we see aggregate 1 is the storage pool in the NAS backend. So as a storage admin, I come and define a storage class called ONTAP mixed. We can see we have a new storage class here, and its provisioner is Trident. So if I go back to the Trident log, we will see that Trident successfully added this new storage class. It's called ONTAP mixed, and this new storage class is satisfied by two storage pools. And if you want to know exactly what those two storage pools are, we can use Trident's REST API to do that. So I'm gonna just use Trident's REST API. Here we see that we have one storage class. If I want to get more information about that storage class, we will see that the two pools that satisfy the storage class are these two pools that we define in the storage class definition. So if a user wants to create a volume of type ONTAP mixed, what the user has to do is to define a PVC whose storage class is ONTAP mixed. And then here we define the other attributes. So the access mode would be rewrite once. Because access mode is rewrite once, that means both the NFS and the iSCSI backend are candidates for provisioning a volume for this PVC, and we want the volume to be of size 20 megabyte. So the user comes and creates a PVC. Before I do that, let me show you that currently the only PV in the storage pool is the one that is used internally by Trident. So I'm gonna create the PVC. And we will see that Trident almost instantaneously creates PV and the corresponding volume for this PVC. So Trident in this case randomly picks from the NAS SVM or the SAN SVM, one of them, to provision a volume. So if you want to get more information about from which backend Trident used to provision a volume, we can issue this command. And we see this in this case, Trident used the NAS backend for provisioning a volume for PVC ONTAP. So we can check the Trident logs here. We can see Trident successfully provisioned the volume and the PV for PVC ONTAP. And I can go to and see that we have a new volume here. The way this volume name is constructed is that the first part, it corresponds to the namespace from which the PVC was issued. The second component is the name of the PVC. And the last 5 characters are the first 5 characters of the PVC ID. So we see that we create a PV with this name that maps to a volume with this name on the storage backend. So now let's look at a different example. Here I'm gonna provision a volume on SolidFire. I'm gonna define a storage class called SolidFire. This is a very basic storage class. In the previous example, I specified 2 backends for my storage class. In this instance, I'm just defining the backend type. So in this instance, I'm saying for storage class SolidFire, the provisioner will be Trident, and any SolidFire backend can be used to provision volumes of type SolidFire. As storage admin, I come and create a storage class called SolidFire. So there should be now 2 storage classes in my environment. I can check Trident log to see the new storage class was successfully added. Now if a user wants to create a volume of type SolidFire, what they have to do is to define a PVC that references a SolidFire storage class. So in this instance, I'm defining a PVC called PVCSF. The storage class is SolidFire. It's going to be of size 2 GB, and the access mode will be read write once. So if a user wants to create a SolidFire storage volume, what they have to do is to create a SolidFire PVC. However, in this instance, we see that the PVC SolidFire does not get bound to any volume. If you're a storage admin and you have access to the Trident log, you can check the Trident log and see that the reason is because currently no backends are available to provision a volume of type SolidFire. And the reason is because I haven't added any SolidFire backend to Trident. And if you're a user and you don't have access to the Trident log, you can describe the PVC SolidFire to get information about its status. So if you do that, here you see that there are 2 messages or 2 events here. The first one is from the persistent volume controller that says it could not find provisioner NetApp.io Trident. This is because Trident is an external provisioner. It's not part of the Kubernetes distribution, so you can safely ignore this message. But the first message, which comes from Trident itself, it says that no available backends for storage class SolidFire was found. So to add a SolidFire backend to Trident, what we need to do is to use Trident's REST API to add the SolidFire backend. So here I have a definition for SolidFire backend. Again, the format is NetApp Docker Volume plugin. In this backend, I'm specifying 3 QoS bands. So the bronze QoS band would basically say if you want to provision a volume whose IOPS range falls between 1000 and 2000, that corresponds to a bronze band. If you want to provision a volume whose IOPS range falls between 4000 and 6000, that falls under the silver storage pool, and so forth. So to add this SolidFire backend to Trident, what I have to do is to use Trident's REST API. And send this JSON file to the backend endpoint on Trident. Now we should have 3 backends in Trident. There are 2 ONTAP ones and the SolidFire one. We can check the Trident logs and see that the new backend was successfully added. And it also satisfies storage class SolidFire. So it should be a matter of time that we see Trident provisions a volume for the SolidFire PVC. As you see, it creates a volume, and the PV for the PVC is no longer in the pending phase, it's in the bound phase. We can get more information about the volume and the PV that Trident provisioned for PVCSF by issuing this command. And here we find information about the LUN that Trident provisioned on SolidFire. So if I go to my SolidFire backend, I'll see that we have a new volume here that is provisioned by Trident. So here, for this to work, to create a volume access group called Trident, I've already created the Trident volume access group in advance. Otherwise, adding the SolidFire backend would have failed, just like the ONTAP SAN backend the first time. As you can see here, there's 6 initiators added to this volume access group. One of them being my host, which I just added to the ONTAP SAN backend. Going back, Trident, as we saw, makes storage provisioning self-service. It also makes storage deallocation on unprovisioned self-service. So if a user is done with the PVCs it has created, all the user has to do is to delete these PVCs, and then Trident would delete the corresponding PVs and the volume. So we can see the PVs are in the release state right now, and one by one these PVs get deleted. So if I go and do kubectl get PV, I should see that the only PV remaining is the one that is used internally by Trident. And I can verify that by going to my storage systems and see that all the volumes provisioned by Trident are gone. So the bronze volume as well as the ONTAP volume are both gone. And I can go to the SolidFire UI and see that the SolidFire volume is also gone. If you're interested to learn more about Trident, please visit the project page on GitHub. You can find more information about storage support in Kubernetes by following the links here. Finally, if you have any questions about Trident, please reach out to us at netapp.io/channel for containers. Thank you very much.